Okay, today we're going to talk about polynomial end behavior, how these polynomials behave at the end of their graphs. Okay, let's say we have the commonly known polynomial x. Let's go ahead and draw it here. I'm pretty sure everyone. Oh, that's too light for you guys. Let's see here. This is supposed to be a parabola, which is actually from the equation y is equal to x squared, okay? This is a parabola, and we say this parabola has an even degree, of course, because of 2. So let's list its characteristics. So let's list its characteristics over here. Let's list its characteristics over here. Now, with talking about these characteristics, we're not just talking about the parabola or the y is equal to x squared graph itself only. We're talking about all even degree polynomials with leading coefficient greater than 0. And we'll talk about that in a second here. Now, when we talk about end behavior, we really only care about its ends, okay? We only care about its ends here. And let me emphasize that we only care about its ends. We only care about what happens. Let me draw that better. As x approaches negative infinity and as x approaches positive infinity. Basically, we care about the ends of this polynomial here. Okay? Now, if we're looking at this polynomial, of course we know what happens as x approaches negative infinity. Well, as x approaches negative infinity, what actually happens here? Well, negative infinity is x approaching negative infinity means x is going in this direction. Okay, that would be the negative infinity direction for x, and this would be the positive infinity direction. Okay, the positive infinity. And then going down here would be the negative infinity direction for y, or if you will, p of x. We'll call this function p of x. And then going up here, this would be the positive infinity direction for p of x, okay? So, as this function, as x approaches, so that means we're looking at the x-axis only, as it approaches negative infinity, so we're looking at this side over here, as it approaches this side, what actually happens to y? What happens to y? What actually happens to y? Well, as x is approaching negative infinity, what is y doing? Well, x, we're going in this direction here. We're going in this direction. But what is y doing? Well, y approaches positive infinity. Or we'll say p of x approaches positive infinity. Okay, great. Now, what happens as x approaches positive infinity? Well, as x approaches positive infinity, what happens to p of x? Well, we're going this direction, but what is p of x doing? Well, p of x is also approaching positive infinity. And you can see that here because let me show you, make more clear what part of the graph we're looking at. Okay, now let's see. I had to pause the video there for a second. We had some malfunctioning. So let me just start over here. Okay, let's start from this point here. So we see what happens as we approach negative infinity. Okay, as x approaches negative infinity, this function p of x, it'll approach positive infinity. And we see as as x approaches positive infinity, we see that this here function approaches positive infinity as well. Okay, let me rewrite this here so that you guys can see this clear. As x approaches positive infinity. Okay, now let's look at a couple of things here. Let's see what happens as our domain. Let's see what our domain would actually be. Well, the domain. We know that this is a parabola, and parabolas have domain of all real numbers. So therefore, we're going to say that it has a domain of all real numbers. Okay? It has a domain of all real numbers. Now, we'll denote this as all real numbers, or we can put it in interval notation here from negative infinity to a positive infinity. And this would be the domain of this here function. All right, now, the range, let's talk about the range here for a second. The range would be all values, okay? The range would be all values that are greater than or equal to our minimum point, okay? That are greater than or equal to my minimum point. Now, my minimum point is this point here, so my range would be all points that are greater than this point here, okay? Greater than or equal to that point there. Okay. Well, we've talked about even degrees. Now, one more thing here. These particular characteristics fall under when degree A is greater than 0. Okay? Now, real quick, let's talk about when it's less than 0 for an even polynomial function. Well, of course, you know what something less than negative coefficient less than 0 is going to look like. It's going to be upside down. It's going to open like an A. Can't draw this straight here. Let me. Okay, so let's go ahead and draw. Let me try this again to draw this parent function here. Okay, perfect. That'll do there. All right. What are the characteristics of this here function when leading coefficient is less than 0 for an even function? Okay, when it's less than 0. Well, let's talk about them here. It's less than 0. Okay. Let's see what actually happens here. Of course we know this direction will be as x approaches negative infinity, and then this direction here will be x approaching positive infinity, and then this direction will be my function p of x approaching, let me rewrite that. My function p of x will approach positive infinity here, and it'll approach negative infinity here. Okay? So let's look here. Let's actually see what we're going to do. Well, what happens as x approaches negative infinity? What happens to this graph here? I'm sorry, what happens to p of x? What happens to p of x as x approaches negative infinity? Well, let's find where x approaches negative infinity at. We're approaching negative infinity here on this side here. So what happens to p of x? Well, p of x actually approaches negative infinity as well. So as x approaches negative infinity, p of x will approach negative infinity. And you can see that from our graph there, okay? Now, what happens as x approaches positive infinity? X approaches positive infinity. Well, what does p of x approach? Well, let's look. As x is approaching positive infinity here, what is p of x approaching? Well, p of x is going in this negative direction here, so p of x is also going to approach negative infinity. Okay? Now, this is what's different. See, these are the different things. This is how we're going to differentiate between a coefficient greater than 0 and a coefficient less than 0. Now, let's talk about the domain and range. The domain, of course, since this is still a parabola, it'd be all real numbers. But the range here, like we said, the range is all values that are greater than or equal to our minimum point. The range here is going to be all values that are less than or equal to my maximum point. My maximum point. Okay. So we know that these values, these are my range values, okay? So we're sitting at my maximum point here, so all range values will be everything that's below this here, okay? Perfect. Now that we've covered our even degrees, we're going to actually stop this video and we're going to do our odd degrees, okay? So let's put this in parentheses so we know what this video is. Even degree. Even degree polynomials, okay, and their in behavior and just some normal characteristics of them, okay. Now we're going to end this video and talk about odd degree.